Here we are, Chapter 10 review. Okay, I'll try to go through this quick if I can. We love Chapter 10, trigonometry. Okay, first place I want to go is to this. I gave you this piece of paper. I told you this is what the top of the test looks like. You need to be able to fill in the blanks. If you want more practice, pause this video, and then you can turn it back on because my next slide is what it looks like. So here you go. Okay, it is possible that you might not have written it in the same order that I wrote it in, which is fine, as long as all these same facts are there. Things that I would say is, another way to write cosec theta equals 1 over sine theta is to say sine theta equals 1 over cosec theta. So it's just showing that they're the reciprocals. Likewise, if you happen to write cos squared theta plus sine squared theta equals 1 and then did your work to follow, that's fine too. So as long as everything is legit, it doesn't matter if it's in the precise order that I've written it in. Okay, on to some problems. Once again, if you want, pause the video, do the problem, turn it back on, and see if you get the same answer as I did. Right, 35 degrees in terms of pi. So, I'm just going to use my quick method that I've been saying. Basically, in the end, what you need to do is take 35, divide it by 180, and slap on a pi. Now, the pi goes in the numerator. So if you don't like fractions, you can type 35 divided by 180 in your calc, hit math, enter, and you'll get a fraction, which is 736. And so this is 7 pi over 36. And if you want to make sure you got it right, you take 7 times 180 and divide it by 36 to make sure it works. Okay, you do need to be able to go the other direction. So if instead it says write 2 pi over 3 radians in degrees, you need to realize pi is 180. And 2 times 180 divided by 3 then is 120 degrees. Not bad so far. Okay, the radian measurement angle is 5 in a circle with radius 3 inches. What is the length of the intercepted arc? So this is about recognition and realizing, oh, that's one of those SOAR problems. S being the intercepted arc, theta being the angle measured in radians, that's important, and this is the radius. So in this case, we're looking for the intercepted arc, so this is a nice friendly one. The radians measure is 5, the radius is 3, so the answer is 15 inches. Okay, you could be given a different problem where instead you're given the S, you're given the R, so you need to realize that the equation then is going to be theta equals S over R. So just be prepared to do whatever you need to do. Okay, I'm not going to ask you in table form to give me the domain and range of all these inverse trig functions, but you do need to know them. So you are either going to be a memorizer or an understander, okay? Now I'm going to sort of go through a method here that I did on the video for this inverse trig stuff, where I kind of thought about the unit circle. So remember, arcsine is just sort of a yucky form. That's my statement. I kind of like looking at it this way instead for sine inverse function. And so we have this whole crazy thing, this restricted domain concept. So sometimes for me, if I get a problem like this, I got to actually kind of go through a process and say, okay, what do I need to do here? Somehow I need to restrict the domain. Now, in the end, the range is going to be -1 to 1. So the whole idea is restricting the domain so that I pick up all the possible sine values. So quadrant 1 wants to always get in the party. Now, the problem with going to quadrant 2 is that the sine values are positive in quadrant 1 and they're positive in quadrant 2. So we would have a case where we have the same values. So that's why we need to go down here to quadrant 4, because that's where we pick up our negative sine values. So that's why we restrict the domain to negative pi over 2 to pi over 2. So then that leads me to be able to answer the question, the domain and range of the inverse function. So the domain then, remember, they just switch positions, is -1 to 1. And the range then is negative pi over 2 to pi over 2. There you have it. So this is your answer. Okay. Given f of x equals sine 3x plus cos x, find the exact value of f of pi over 2 and simplify. So, it's function notation. It can pop up whenever you least expect it. So if someone asks me to figure out what's f of pi over 2, I really have no choice but to take that and sub it in. So in place of the x, I'm going to put in pi over 2 plus cos pi over 2. So this really is the sine of 3 pi over 2 plus the cos of pi over 2. Now I'm not going to get into the nitty gritty of how to figure this out. You have options. I mean, you could change your calc to radians, and if you're not sure where 3 pi over 2 is, or you could turn this into degrees, 3 times 180 divided by 2. But somehow you got to get yourself into the zone of what the heck is the sine of 3 pi over 2. And this really actually is the sine of 270, which is negative 1. The cosine of pi over 2 is 45, so the cosine is radical 2 over 2. Exact being the key word. So when it says simplify, I don't want to leave that as 2 chunks. So I'm going to go ahead, I'm just going to pick up a different color here. And I'm going to bring this together in one fraction. So 2 would be a good common denominator. So I'm going to multiply the top and the bottom here by 2. So I end up with negative 2 plus radical 2 all over 2. And it's okay to leave it like that. If you wanted, you could rewrite it as radical 2 minus 2 over 2, but that's really not necessary. Okay, moving right along. This one is all about, do you know how to push the buttons on your calc? If you're told the cosine of theta is 0.7321, what is the, here's where reading matters. What is the radian measure of theta to the nearest 10,000? So you need to make sure your calc is in radians. And so theta then is just going to be second cos on your calc, 0.7321. So as long as you push the right buttons that are in the right mode, out should come 0.7494. 10 thousandths then, 4 places. You must also know that, so you round to the right position. Okay, number 7. Sec theta equals cosec 2 theta minus 30. What is theta in degrees? Recognition. Sec theta, cosec theta, co-functions. Therefore, this guy and this guy must be complements, as in they must add up to 90. So, theta plus 2 thetas is 3 thetas minus 30 equals 90. Little quick algebra here. 3 thetas, 120. Divide it out, and we get theta equals 40. Okay, next one. 8. Write cosine pi over 6 in terms of its cofunction in radians and give its exact value. So I talked about, like, you could just do this all in radians and just sort of deal with fractions, but if that makes you uncomfortable, you can change pi over 6 into degrees. You might be able to deal with that better. So 180 divided by 6 is 30. So the cofunction of cos 30 is sine 60. But since I need to be in radians, then I need to have the ability to change 60 back into radians. So that would be the sine of pi over 3. And then it asks me to give its exact value. And once again, at this point, like, you got to either know what the sine of 60 is, or be able to use your calculator, making sure you're in the right mode. So the sine of 60 then is radical 3 over 2. Now personally, I always think like the sine of 30 is a half, so the sine of 60 can't be a half, so that helps me remember that. Okay, rewrite the following in terms of sine theta, cos theta, or both. These problems have everything to do with being able to change things that you see into other forms. So that sec squared theta minus 1, to me, is screaming to look back. Let me go all the way back here for a quick second. To look back at my beautiful list and say sec squared theta minus 1. Well, here is a sec squared theta, and if I were to just take that plus 1 and move it on over here, suddenly I have determined that sec squared theta minus 1 is actually tan squared theta. So now, you join me for the ride back to that problem I'm working on. I am going to replace this sec squared theta minus 1 with tan squared theta. And I still have this cos theta over here. But my job now is to get this into terms of sine and cos, so I got to do a little bit more work here. So I'm not going to go all the way back to that other screen again, but if you remember, tan theta is sine theta over cos theta. which is tan squared theta then, is sine squared theta over cos squared theta. So now I have a cos theta on top and a cos squared theta on the bottom, so this cos theta can take out one of those cos thetas on the bottom. So in the end then, this is sine squared theta over cos theta. Okay, another one over here. It's really more the same. I'm not going to go back to that other screen. And you know, if you're taking the test and you have that written out, you can look at it as a reference. So the secant theta is the same as 1 over cos theta. The cotangent of theta is cos theta over sine theta. And the cosec of theta is 1 over sine theta. So all I'm doing is subbing in. Now I know there's a little kind of fraction-y action going on here, so you need to be careful. When you multiply, if I get something the same in the numerator and the denominator, they really just divide out to be 1. So now I have 1 over sine theta in my denominator divided by, I'm sorry, numerator I meant to say, divided by 1 over sine theta in my denominator, so I'm going to change to multiplication and flip this guy. And so in the end, believe it or not, these guys go away because they divide out to be 1, and this darn thing turns into a 1. Doesn't always happen that way, but in this case it did. Okay. Find the value of the expression. Okay, in the video I did on this, I just can't help myself. I just don't like that notation, so I always change this over to tan inverse 1. So, you need to figure out what is the cosine of the angle whose tangent is 1. So if you don't know what that angle is, then use second tan, throw in a 1, and get the angle. Just always be aware of what mode your calc is. So in the end, this is 45 degrees. Now, you need the cosine of 45 degrees. So if you don't know what it is, once again, use your calc. Maybe get used to, seeing the various decimal forms. So this is radical 2 over 2. Hopefully some of this unit circle stuff, though, is kind of, you're feeling it, because you remember that. Cos of 45 is radical 2 over 2. Okay, so here's another one. The sine of the tan inverse of 6 over 8. Now, I will be honest, you could really just push buttons on your calc carefully and then hit math enter enter and get a number out. But I want to kind of go back over with you what this means. The tan inverse of 6 over 8. Remember, it means that there is some angle whose tangent is 6 over 8. And remember the old TOA. So that means that the opposite is 6 and the adjacent is 8. So now you need to figure out what this is, and this is actually a rather famous right triangle of 6, 8, 10, or you could use your Pythagorean theorem. So now I need to find the sine of this angle. And if you recall, sine, so, is opposite over hypotenuse. So in the end, the opposite of this angle is 6, and the hypotenuse is 10, and I'm going to go ahead and reduce that to 3 over 5. Okay, we're getting there. Slowly but surely, just a couple more problems. I'm not going to do a bunch with this. You do need to know where functions are undefined, so I could give you a bunch of different ones, and I need you to be able to tell me where they're undefined. Now, I'm going to do a simple one, just as an example. Now, there's different ways to do this. You can look at it on your calc. I kind of have a preference. I just sort of think about my unit circle. And if it's tangent, I remind myself that that is equal to sine theta over cos theta. And I know I am not allowed to divide by 0. So trouble, as in undefined territory, happens when the cosine is 0. And cosine in the unit circle has to do with the x value. So that happens at this point and at that point. So this in my unit circle is 90, and this is 270. So I'm supposed to zip around my unit circle from 0 included all the way through 360 included. So in this particular case, I would just say it's undefined at 90 and 270. And if you want to check it, you can go ahead, hit tan 90, see what comes up, tan 270, and you'll see that. Okay, this would be the last problem. Sorry for the scribbling. I decided to change the problem. Basically, this is one of those lovely problems that you are given the sine or whatever it may be of an angle, and then you need to find the 5 other function values. Now this one is in quadrant 3. That's the reason this guy's negative, because it's in quadrant 3. Y is negative down there. So as I've said on my videos, for me, just to start feeling better about the whole problem, the first thing I do is the reciprocal. So the reciprocal of sine is cosec. So the cosec is negative 5 over 3. I'm off and running. 1 down, 4 to go. Okay, the next move that I would probably make is using this relationship. And I would say, well, I know what the sine is, and I just need to square it. So negative 3/5 squared plus cos squared theta equals 1. So negative 3 over 5 squared is 9/25 squared plus cos squared theta, and this would be equal to, I'm just preparing this fraction. Now, if you don't like fractions, you can cheat with your calc and just leave that at 1, because in the end, I got to subtract 9/25 from both sides, which you could just do with your calc, 1 minus 9/25. So cos squared theta then is equal to 25/25 minus 9/25 is 16/25. And then I'm going to take the square root of both sides, and sure enough, the cosine of theta is equal to 4/5. Now here's where trouble could occur. Remember, in quadrant 3, all students talk constantly. Tangent's the only thing positive. So this is negative. So you got to pick that up, because the solving out I just didn't pick that up for me. Okay, 2 down. Let's get to 3 down, because the reciprocal of cosine is secant. So I just flipped that sucker, and now I have 3. So 2 more to go. The tangent of theta is equal to the sine of theta over the cos of theta, and I have both of those. Okay, so from the beginning of the problem, the sine is negative 3/5. The cosine, which I just figured out, is negative 4/5. And so I negative divided by negative is a positive, so I have 3 over 5 times 5 over 4 equals 3/4. I see the light at the end of the tunnel. So I now know that the tangent of theta is 3/4, and it's positive because I'm in good old quadrant 3. Okay, one more. Flip that guy, and you are fini. Done. Okay, that's all I have. Hopefully you're getting this stuff. I know trig can be a little wild and crazy sometime, but just hang in there. The more you practice, the better you'll get.